Hey guys!
Hello there!
Welcome back this week. So we're going to put out some pre-activities for you guys to do, or hopefully you guys already did them. If you guys didn't do them, you can go back and see the pre-activities that we did post for you guys.
Yeah.
So we're going to be posted a water cycle activity, and then we also gave you guys a water calculator at watercalculator.org so you guys can see how much water you guys actually use on a daily basis. And then for this water cycle activity, it's very easy. All you need is a plastic bag. Make sure you use something like duct tape to tape it onto like a window so then you can see the precipitation happen, and then also how it comes down. So it's super fun.
Yeah, it's really awesome. You can see it like condensating on top of the bag where you might draw some of your clouds, and then you can see it fall back into your ocean.
Yeah, and then you guys can even post a picture. If you guys did the activity, post a picture in our comments and kind of show us what your water cycle looks like.
Yeah, definitely. So, if you haven't figured out what we're talking about this week, our episode 4, which is the last of this series of Ranger Roundup videos, is going to be revolving around water, and it's called Danger, Slippery Slope Ahead. And there's a teardrop falling in the water. So, yeah. We're going to be talking about water this week and all about water. And this is also going to be a 2-part video like our soil one, just because water is
Pretty interesting.
Yeah, pretty big topic.
And you're going to figure out later in our part 2 why we're calling it slippery slope.
Yeah. So, with that, this is going to be our 4th Ranger Roundup episode, the last of this series. And we do have some activities or challenges for you for part 1 of this video, and then we'll give you a closing activity for part 2. So, Rachel, would you like to tell them about the part 1 challenge activity that we have?
So the activity challenge for you guys is going to be trying to lower your calculator score from the previous pre-activity at watercalculator.org, and then we're going to give you a link for a footprintcalculator.org, which is going to tell you how many Earths you actually use, and it's like in a year, right?
Yeah, in 1 year, how many Earths, if everybody lived like you, how many Earths would we need to survive for 1 year? So that's going to be pretty interesting.
No, definitely.
To see.
I was going to say, I was surprised when we did.
Yes, I was very surprised too.
I felt very bad.
Yeah, definitely more. I would need more than 1 Earth to survive. So that's kind of shocking. But you can learn a lot, and you can figure out what's contributing most to what you're doing on a daily basis, and what's contributing to the resources you're using. And how you might be able to conserve some of those resources, which will also lead into the part 2 of our water series. So, yeah, and next we're going to move on. We have a new ranger that's going to be joining us today. So she's going to be talking about the water cycle.
Hi guys, my name is Marielle. I'm one of the other rangers here. I'm usually the voice behind the camera. And right now I'm going to talk about the water cycle and what that does. So when we talk about water, I want to give you guys a couple of minutes to think about where is water and where does it come from. Okay? So most of the water that we interact with, when we think of where it comes from, most people will say rain. Some people will say the ocean or a river, or that kind of thing, but water still has to get to those places. So one of the ways that we talk about that is something called the water cycle. Okay, so this is a little bit more complicated. I'll show you a simpler version here in a little bit, but this kind of shows the water cycle of how water typically gets from our bodies of water. Here in Florida, the closest and easiest way to think of that would be like the Gulf of Mexico or the Atlantic Ocean. But water stays out there, and through a process of either evaporation or transpiration by the sun, they form water vapor that goes up into the sky. And as those water vapors kind of congeal and coalesce into something like a cloud, and eventually that cloud has so much water vapor that it comes down in the form of precipitation. Precipitation are things like snow, rain, sometimes fog is a type of precipitation as well. As it flows down, that's typically what we see when we see it come down on a thunderstorm or snowstorm. Those are things that we can touch, we can feel, we can play with in the wintertime. And then at some point, that water has to go somewhere. So most of that water ends up in places like lakes, rivers, where it becomes collected, and then it goes out towards a major body of water, again in Florida, where we are, Gulf of Mexico. So, the water cycle. You at home can also make your own water cycle. We have one activity here. Okay. So we have body of water here. And this particular one, it has a spinner plate. So you can follow where the water is. As you spin it, you can see how the water droplets evaporate and condense in the sky from the sun, falls to the earth in the form of precipitation, runs off into a river, and then runs off into the ocean to begin the whole cycle again. And this one, you guys can kind of see it, will rotate. Okay? That is the water cycle. I will leave these resources up for you on our website and YouTube as well soon.
All right,
Hi
welcome back.
guys.
So we just had Ranger Marielle talk to you guys about the water cycle. So hopefully you learned about how water kind of cycles from the ground into the atmosphere and then back down to the ground. And hopefully you can see some of that with the activity that you did, if you did the pre-activity. Or if you didn't do it, now is the time you can do it.
Yeah, and have fun filling out that water cycle exactly too, because that's gonna be fun.
Yeah, that's
Fun
true.
color.
Mm-hmm. And you can color it just about
Oh,
anything you
yes.
want. I've seen people color the mountains ice cream before, cotton candy clouds.
That's
So you
awesome.
can really get as creative as you want. So hopefully you guys get to do those and you really enjoy them. But now we're going to move on to talk about kind of the composition of the water that's on our Earth. So we know how it cycles from the ground, the air, back down to the ground. But where can you find it on land, or on the Earth, and what is all that water looking like? So if you're thinking about the Earth and the globe, Rachel, when you think of looking at Earth from space, what two major colors do you see?
I see green and blue.
So yeah, you would see green and blue. And do you think do you normally see more green or more blue?
Probably more blue.
Yeah, awesome. So that's also correct. You should hopefully see more blue than you see of green. And that's because 71% of the Earth's surface is water, covered in water, which is a pretty big portion of it. It's
yeah, it is
yeah,
a lot.
It's
when you
over
think about it.
2/3, yeah. So over 2/3 of the Earth's surface is covered by water. So when you look at a globe and you see that nice green and blue, you're gonna see more blue. Just because there's much more water covering the Earth's surface than there is land.
How much of that water can we actually use though?
It's a great question, because when you think of water, you're thinking of probably oceans.
Yeah.
That's what's covering most of the surface. And you would be right, 97% of the Earth's water is going to be seawater.
Wow.
So yeah, that's a lot, and that's kind of cool. That's why we have all those sea critters living there. But that's not too helpful for us in terms of our drinking water and the water that we need to go about our daily lives. So of the water that's left over, there's only about 3% that's fresh water, which is the water that we can drink. But of that 3%, only 0.5% of that is going to be drinking water that we can get to. The other 2.5% is going to be found in glaciers, ice caps, icebergs, and in the air. So all the water that's like in our clouds as well. So of the 71% of the Earth that's covered in water, only 0.5% of that water can actually be used by us.
Doesn't even seem that much, honestly.
It
It's like
doesn't.
crazy.
Right? It doesn't seem like we should be able to even have drinking water on tap. So it's really interesting to think about just how much fresh water there is actually on the surface, and then comparing that to how much we use it on a daily basis and don't even think about it. So that's why we kind of gave you that water calculator activity to do, to see how much water you use on a daily basis, and see how maybe you can cut that back, because we don't have too much fresh water, and we need to make sure we keep all that fresh water clean and usable for us and for people to come in the future. So, as I was talking about, we have 0.5% of our water that's fresh water that we can use, and we'll talk about the ways that we use it in our second video. I know you have a lot of stuff to talk about the fresh water, but there's still 97% of the water left on Earth's surface that we don't talk about as much. So, what I'm going to be talking about is kind of our seawater and how it moves across the globe. Because our fresh water we can find in lakes, rivers, streams, but how is our seawater moving around and helping out the ocean life and also helping out us? So this picture right here, we will be posting these online so you can see them a little bit up close, because I know they're not the best quality from far away on a camera. But these right here, this is a picture of our Earth, and these 5 little circles are things called gyres. So if you think of the water, you think of the ocean, usually some things that come to mind are currents and tides. Waves.
When you get hit by a wave.
Exactly, when you get hit by a wave. But there are these things called gyres, which is kind of a funny word.
I know, I did not know this before. What is that? It sounds like a rock.
Exactly. It doesn't really sound like what you would think it is. So these gyres, they're kind of like big whirlpools, if you kind of want to think about it that way. They're a little bit different than a whirlpool, because whirlpools, if you think about making one in your actual pool at home, they kind of like spin you around and you're going crazy. But if you get in the water, you're not necessarily going to feel that pool as intensely, but it works the same way. So if you are here in the North Atlantic, I'll actually pull up this picture, it's a little better. You can see that this gyre is in the northern part of the Atlantic, and it has currents pulling it along. So currents are what make up these gyres. Currents are the way all the water is flowing from side to side, whereas tides are going to be moving the water up and down. That's why we have a high tide and a low tide. But the current's going to be where that water is actually moving to. So you have your current right here in North America, or the North Atlantic. It's going along our eastern coast of Florida through the Gulf Stream, and it's going to head up and then come back down along the equator. The reason,
Is that the same thing as like in Nemo, like when they're like riding on the waves?
Yes, exactly. It's the same thing as in Nemo. So in Nemo they ride the East Australian current. And that East Australian current is going to be right over here in the South Pacific gyre. So you'll notice that there's northern gyres and southern gyres, and that's all due to the equator and how our Earth spins. So our Earth spinning and the wind kind of moving is what's going to cause these currents to start moving, and they're going to create those gyres. So as the wind moves along the equator, it's always going to move from east to west, and that's going to cause the currents in the northern hemisphere to go clockwise, and the currents in the southern hemisphere to go counterclockwise. So they're making those nice little whirlpools, but they're going opposite directions, which is why we have 5 of them. So you have your northern Pacific, southern Pacific, northern and southern Atlantic, and then your Indo-Oceanic, which is going to be where your Indian Ocean is. So you have all that moving around the water on the surface, but you also have, I have it in my hand already, something called a thermohaline circulation. So this is another way that water is moved throughout the ocean. So it doesn't just move on these surface currents, but it also moves throughout the ocean, under the water, and on the surface. So if you look at this, you'll notice this water, if it's blue, it's down in the deep part of the ocean, and when it's red, it's on the surface. So you'll notice it moves along the whole globe. It comes up to Greenland, Iceland. That warm water starts to get really cold, and it actually sinks down into the water. And then once it sinks down into the water, travels through a cold path, and will eventually warm back up again and come back up to the surface. And that's how a lot of nutrients and oxygen and carbon dioxide will travel to the bottom of the ocean. Because we don't think of the bottom of the ocean as having too many critters, but they actually do have some critters down there that need things to survive, like nutrients. So that water helps bring all those nutrients down to all those animals that are living underneath, which is really cool. So your ocean is kind of moving in a way that's going to help all your animals get to where they need to be, but also help them get the nutrients that they need to survive as well. And this is also going to play a large role into our part 2 when we talk about humans navigating things, because our surface currents are going to help pull boats along, and are going to be the main ways that boats, if they can't move against the current, that's the way they're going to kind of go. And it's also going to help us when we're talking about litter and pollution. When things fall into the ocean, they'll follow these currents as well. So there was a story one time of some tennis shoes falling off in the northern Pacific gyre, and they traveled all the way from one side of the coast, eastern part of Asia, all the way to the west coast in California, and we're washing up in Alaska and California as well. Yeah, so our currents play a large role in how things get around, and how we use the water throughout history as well.
Alright guys, well I hope you had fun this episode learning about gyres and also the tides and then kind of the water cycle, and had fun with those pre-activities. We're going to be coming to you guys next week, and we're going to be talking about how human use and like human effects with the water and different kinds of stuff like that. So we'll see you guys next week, and check out and keep your eye open for a pre-activity for that week. Alright? Bye guys. Stay safe out there.
Bye.